So if I want to show the variable capacitance, I'll just use a small space on this side. So as voltage decreases beyond this biased value, let me call it V bias, as the voltage decreases, in that case the capacitance will first increase, and as the voltage increases, then the capacitance will decrease. So this constant value we have already called it as CD, and the maximum value by which the capacitor change on both the side will be nothing but delta CD. So a typical values of variable capacitance offered by varactor diode will be in picofarads. For example, for any typical varactor diode, you may obtain the variable capacitance over the range, let's say 10 picofarad to 150 picofarad, for example. So the minimum and the maximum value of the capacitance will decide the minimum and maximum values of frequencies that you can generate. For example, F4 minimum that will be generated will be equal to 1 upon 2 pi under root L into C plus delta CD. So this is the maximum value of the capacitance, and hence F4 will be minimum. On the other hand, maximum value of the frequency will be obtained when capacitance takes its minimum value, which will happen when the value of the capacitance is C minus delta CD. So this is my maximum value of the capacitance, which will generate minimum frequency, and this is minimum value of the capacitance, which will generate maximum frequency. And please remember that F4 min and F4 max, if they are exactly the same values, which will be the case if the change in capacitance is exactly same on both the sides of this midpoint biased value of CD, in that case delta F, which is nothing but frequency deviation, will be given as F4 max, which is the maximum instantaneous frequency, minus F4, or it can be given as delta F equal to F4 minus F4 min. So that's my frequency deviation. And further, once you decide delta F, you can decide your mu F as delta F upon Fm. So to obtain large values of modulation index, you will need large values of frequency deviation, and for large value of frequency deviation, you will need a large gap between F4 and F4 max, or F4 and F4 min. And to obtain large gap, you must simply have the large range over which the capacitor is changing, and hence in that case you need large value of delta CD. So the final conclusion says that it is very difficult to obtain large range over which capacitor can be varied if you use a device like varactor diode. Varactor diode can give you variable capacitance but not over very large range, and hence the range over which F4 can be changed will also not be very large. And hence the use of varactor diode is suitable in generation of narrow band FM, where delta F should not be very large, or in other words mu F, the modulation index, should not be very large. If you want to generate a wideband FM, or even if I don't talk about the types of FM, if I simply want the range, the large range over which the frequency should be changed, then I should be using a better variable capacitor device or a circuit. So the next option is of reactance modulator. Using reactance modulator, which is not a single component like varactor diode, it's a group of components, we can generate FM signal. So the circuit remains exactly same as the as we had shown previously. So in place of this varactor variable capacitor block, we will be placing this whole structure of varactor diode with DC biasing and the input signal of M of t. Let us now discuss the second option of variable capacitor.